Hello everyone, this is Mr. Wu, and this is the second part of my review of the 2023 VCAA Methods Exam 2 Extended Response questions. The first part ended here, so I'm just gonna carry on to the next question, question 4. We have tennis balls, and we have a manufacturer. The diameter of tennis balls is a normally distributed variable, and it's letter D, and the mean is 6.7. So I've written down the mean symbol, the mu symbol, and the balls have a standard deviation of 0.1 centimeter, the diameter of the balls. So I've written down sigma equals to 0.1. Okay. And then first question is find the probability of the diameter bigger than 6.8, correct to 4 decimal places. So that is a calculator question. So probability, distribution, normal CDF. So the lower bound is 6.8, the upper bound is infinity. Mean is 6.7. Standard deviation is 0.1. 0.1587, correct to 4 decimal places. And then it says find the minimum diameter of a tennis ball that is larger than 90% of all tennis balls produced. Give your answer in centimeter, correct to 2 decimal places. So questions like this, I always like to visualize it. So draw a quick graph. So there's some point I'm trying to find. So this point here. This point here is what I'm trying to find. This point here, this number here. And then to the left of this number, the area is 0.9. Which means this is is an inverse normal question. So the area is 0.9 I'm looking for. I forget again, the mean is 6.7. And 0.1 is the standard deviation, and that's the answer. Okay, next up. Tennis balls are packed and sold in cylindrical container, and tennis ball can fit the container if the diameter is smaller than 6.95. Find the probability that a randomly selected tennis ball can fit through the opening of the container. So I need the diameter smaller than 6.95. So 6.95 is the biggest diameter. 6.7, 0.1, 0.9938. And then in a random selection of 4 tennis balls, find that at least 3 can fit through the opening. Well, selecting 4 balls from a bunch of them means you have trials, you have 4 tries. Also, because there are so many tennis balls, we can assume that the chance of picking a ball that fit does not change from one trial to the other, which means this is a binomial. And which means you need to make a new variable and you need to define it. So you need to say let x be the amount of balls that fit through the container, and it's a binomial distribution. So number of trials is 4. Chance of success is 0.9938 because that came from the previous question. And then you put that into your calculator. So manual 55, and you go to binomial CDF. So 4 trials, probability of success. This much. Lower bound is 3. Lower bound is 3, upper bound is 4. And that's the answer. 9998. And then a tennis ball is cast as grade A if the diameter is between 6.54 and 6.86. Otherwise, it's classified as grade B given, so a keyword here, keyword right here, given the tennis ball can fit the container, find a probability that it is classed as grade A. So it's a conditional probability question. So between 6.54 and 6.86, given that D is less than 6.95. Well, it's a conditional probability, so it's a fraction, but the numerator is the intersection between the two conditions. Oh, sorry, I shouldn't say that, between the left and the right. So because this range is smaller than less than D is smaller than 6.95, the intersection between this interval and the right interval is just the left interval. The intersection between the two intervals is just the left interval because it's a smaller interval. And we have that probability already, I think. Do we have that? Oh, no, we don't. So that's a calculation on the cast. So this normal CDF, so the 6.54, 6.86, then 6.7, 0.1. So that's where the 0.890401 came from. And I have written down a lot of decimal places because you only round, and please do this, you only round at the very end. Every step, intermediate step, in between your first line and your last line should not be rounded. It should be as exact as possible. And the probability of D less than 6.95 is it's a very similar concept, normal CDF. You get this number and you divide and you get a final answer. Okay. This question. I will read my blue comment in a moment. So the manufacturer needs to improve the process to ensure that more than more than 99% of all tennis balls produced are classed as grade A. Assume that the mean remains the same. The mean is the same. Find and require the standard deviation of the diameter correct to 2 decimal places. Okay, so I need a new variable because the standard deviation is different now. So the whole distribution is different. Right, so let y be the diameter. So y is a normal distribution. The mean is still 6.7, and the variance is whatever standard deviation I'm looking for, and then squared. So the probability, I want the probability of 6.5 of the new diameter, which is y. I want the probability of y between 6.54 and 6.86 to be 0.99. I know the question says more than 0.99, but let's deal with equal to 0.99 because it's easier. So I haven't written bigger than, I've written equal, 0.99. Exactly, 0.99, not more than 0.99. And that means, I did this with a visualization in my head, so I didn't draw it, but I should draw it here. So this one here, 6.54, something here, 6.86. So in the middle, it's 0.99. The area is 0.99. But that means to the left of 6.54, the area is 0.005, 0.005 in the middle, because everything outside 0.99 is 0.01, and so I have to divide that by 2. The graph is symmetrical. So this left area and the right area, they are symmetrical because 0.99 is in the middle. So I have 0.005 on either end. Yeah, I think that's the middle. Hang on, let me double check. 6.86 plus 6.54. Yeah, 6.7. Yeah, the mean is in the middle. It's at middle. So the mean 6.7 is in the middle of 6.54 and 6.86. So it's good. Okay. So the area to the left of 6.54 is 0.005. That's important because now I'm going to define Z. Z is the standard normal. So standard normal distribution. And standard normal just means this. The mean is 0 and the standard deviation, in this case really a variance, but it's really standard deviation that we care about. Standard deviation is 1, even though technically in the bracket it's a variance that we write down. So mean is 0, standard deviation is 1. That is a standard normal distribution. What I want now is I want to convert between y and z. Why is that? Because I can calculate the area on the z scale. So this is the y scale. On the z scale, I can calculate this. Whatever this A is, the area is 0.005. Right? There's some area, 0.005, to the left of some value, A, and I can easily find out A. In the standard normal distribution, I can easily find the A point, where the area to the left is 0.005, because I know the mean and standard deviation. Right? By definition, the mean and standard deviation is given to me in the standard normal, 0 and 1. So I can do this. What I mean is I can do this. Manual 5.5 and then inverse normal 0.005, I think. Yep. And everything else is in standard. So negative 2.5759. So I know, sorry, 5758. So I know what A is. On the standard normal, A is this value. But there is a relationship. There's a relationship between the value in the Y scale and the value in the A scale. If you recall, standard normal is nothing but a measure of the distance between any number on the Y and the mean Y value. Okay, so if you take some number on the Y scale minus the mean of Y, which is 6.7, that's the distance, right, between that number and the mean. And if you measure that distance in terms of the amount of standard deviation in the Y scale, that's your Z score. So normal distribution is also called the Z score. So Z score measures the distance from a data point to the mean, and it measures the distance in terms of the amount, the number of standard deviation. So if we take 6.54 minus the mean divided by its the standard deviation of y, it divided by its standard deviation, which is the standard deviation of the y variable, it is equal to the Z score, the Z number. In this case, it's negative 2.5758293. They have the same area. They have the same area to the left. So from this, I can work out. So this comes from the definition of Z score, which is also the standard normal. Which is also the standard normal. And from this equation, I can work out the standard deviation of y, which is 0.06. So if you solve this equation, you get the standard deviation equals to 0.06. Question I have written down for myself. Which one? Is it equal to 0.07 or less than or equal to 0.07? The reason I first wrote down the last line, the sigma less than or equal to 0.07, is this. The question says more than 99% of all balls are class grade A. It's like this. If you make the standard deviation smaller, the graph becomes narrower. Right? So the graph may be like this when sigma is 0.07. But if you decrease sigma, if you decrease the standard deviation, it's going to look like this, right? So the smaller the standard deviation, the more percentage of tennis balls will be grade A. They will be inside this range here. So, and I repeat, the smaller the standard deviation, the more balls, 99.5%, 99.6%, 99.999% of balls will be grade A because they will be within this range. So the answer should be less than 0.06, and we can check that. Right? So normal CDF. So I want 6.54, and I want 6.86, and I want 6.7, and the standard deviation. Let's try our answer, 0.06. Right, 99% of tennis balls are within the grade 8 range, but try that. Let's decrease the standard deviation. Even more balls are grade A. Wait, what did I do here? Yep. And then decrease the standard deviation again. Even more balls are within the A grade. Right? So if we are looking for standard deviation that gives more than 99% of tennis balls being grade A, you can have any standard deviation less than or equal to 0.06. But and corrected to the 2 decimal places, because try this. If we do 0.07, then it won't work. It's 0.98. So it has to be 0.06. If we correct to 2 decimal places, it's going to be 0.06. It can't be 0.07. Correct to 2 decimal places, because that's what the question says. Okay. So that's my first reaction, right? The standard deviation is less than 0.06 or equal to. But if you look at the question again, here it says more than 99%, which means I can have multiple answers for the standard deviation. But here it says find the required standard deviation, singular. Look at this noun here. It's a singular noun. There's no S. There's no S at the end. It's not plural. So it looks like the question is asking for a single number for the standard deviation, which means technically, if I just guess, right? If I type those in, right? So I need the balls to be between 6.54, 6.86, 6.7 for the mean. And if I just guess a standard deviation, like this, and it gives me more than 99% of balls being grade A, I can just write it down without working, right? I can just write down 0.01, and it's correct. And it's correct. This standard deviation gives me the required amount of balls within grade A. So if the question is asking for one answer, then it's very easy to guess because there are infinitely many answers to it. So, and to make it very narrow, more than 99% within the range just means the graph is very narrow, which means you can just pick you can just guess a very small standard deviation to make the graph narrow, therefore to make a lot of balls within the range. So can we do that? Well, I don't know. So that's my comment, right? It's an ambiguous question. More than 99%, but it does not ask for the largest standard deviation to achieve this. It just asks for the standard deviation to achieve this. So if we just look at the fact that it says more than, and it doesn't say largest standard deviation, then we assume we're giving the less than or equal to response, the range response. But then it uses a singular noun. So what is it? Is it 0.06? Just one number, or any one number that's less than that? Would that suffice? Would that be enough for 2 marks? I do not know. Again, it's very easy to fix this. find the largest, GEST, largest required standard deviation, and that'll be done. That'll be good. Or, so either VCAA could have added the word largest, or they could have said find the range of standard deviation that can achieve this. Next, how much longer is this? An inspector takes a random sample of 32 balls, and they have a confidence interval of the population proportion of grade A balls. The confidence interval is given to you, correct to 4 decimal places. Find the level of confidence that the population proportion of grade A balls is within the interval. Is a percentage correct to the nearest integer. My problem with this question is this sentence right here, the sentence that I have circled, is not the most pedantic, correct, rigorous interpretation of confidence interval. A confidence interval doesn't mean the population proportion is within this interval with 95% confidence, let's say, or 90% confidence, or 91% confidence, doesn't matter. We can't say that. You cannot say you get a population, you get a proportion number, and then you say, I'm 95% confident that this true population proportion is within this range. It doesn't work like that. It is, you pick 32 tennis balls, you get a sample proportion, and you get a confidence interval, and you put that away. You write them down, you put it away. And then you do another 32 samples, and you get a different sample proportion, and you get a different confidence interval, and you put that away. And you do another sample of 32, you get yet another different sample proportion, you get yet another different confidence interval, like this, you put it away, and so on and so forth. And you repeat that 1,000 times, 10,000 times. And then you say 95% of those confidence intervals contain the true population proportion. So that's what confidence interval means. So this sentence is a misconception of confidence interval, although it doesn't affect the doing of the question. I mean, in practical sense, how to do this question, it isn't really affected by the sentence, the misconception here, but it is nonetheless a misconception of confidence interval. Okay, so from the confidence interval, we know what p hat is, at least. P hat is always the sample proportion. This is the sample, not the population, the sample. The sample proportion is always in the middle, so add the two numbers, divide by 2, that's the middle. And then you have your confidence interval formula in this one here. That's the confidence interval formula, and you know we have just calculated p hat here. So you sub that in. The Z you don't know because Z tells you the level of confidence. So that's what we're trying to find. Right. Z is what we're trying to find. And then p hat you know, which means you know what 1 minus p hat you also know. And then n is the sample size, which you do know also. The sample size is 32. So you sub everything in, and one's the left and one's the right. So I'm gonna, what did I pick? I picked the left one, I think. Yeah, so the minus, I picked the minus one, which is the left point of the interval, confidence interval, and that's equal to 0.7382, which is given in the question. So for Z is that number. And then, this is what's not in the formula sheet. Z is this. What does Z mean? Well, I've got a Z value of 1.644. If you put the Z value into the standard. This is the standard normal. The standard normal variable, the positive and negative, and find the area between that, positive 1.644 and negative 1.644. That percentage is the confidence level. So that's what Z means. The meaning of Z, you also need to know. You need to take that number, put it into standard normal, one positive, one negative, and find the area, and that's your confidence level. And so what I mean by that is this, and then you keep the 0 and 1, you keep the mean and standard deviation, and you change the lower bound and upper bound. Okay, and then we have a tennis coach. They use both grade A and grade B balls, and then there's a serving speed, meter per second, of a grade A ball is a continuous random variable with a probability density function this. So V is the speed and the probability density function is F. Find the probability that the serving speed of a grade A ball exceeds 50 meter per second. So probability is just the area under the function. So from 50 to the highest speed possible, 3 pi squared plus 30, integrate the F function and we get the answer. And then it says the exact mean serving speed. The mean is integration, the definition of mean is the integration of all the domain, and then the variable times the function, and you integrate, and calculator, this is all calculator, and you get the answer. And then you have the serving speed of grade B balls, and it's the probability density function is W. Sorry. The speed is W, and the probability density function is G. And it turns out that G is a transformation from F. There's an A and there's a B. W is the speed again, so A and B are the transformations. A and B represent the transformations. And it says the mean speed is 2 pi squared plus 8. Find the value of A and B. So I'm just going to write down what G is. I sub W over B into F and then times A, and this is what I get. The rule is straightforward to write down, but the domain. Okay, the domain is in terms of V, but in this case in terms of W. So domain is in terms of W, which is equivalent to V. Let's look at A. Does A affect the domain? The answer is no. A affects the Y values, so it doesn't affect the domain. The domain is the X values. But the B does. So B affects the X value. In this case, X value is equivalent to W value. It's the horizontal value, horizontal axis. So B basically takes the domain, both endpoints of the domain and times B. Right? It's in the bracket. It's W divided by B, but the actual dilation is times B. It's always the reciprocal of what's in the bracket. So W divided by B means the domain, the endpoints of the domain, and every W point, the X value has to be multiplied by B. So we take the domain from before, 30, that's the endpoint on the horizontal axis. 30 times B is what we need, and the other domain, the other endpoint of the domain as well. So this is the X value. It's V, but it's X value. X value times B is the dilation. So that's the other new endpoint of the domain. Once we have this, we can write this. The entire area under the function has to be 1, and the mean. So integrate over the whole domain again, but the mean is W times the function. So the independent variable times the function. That has to equal to 2 pi squared plus 8. So you put those two into your CAS calculator and solve simultaneous equations, and you should get A and B. Right? Two conditions. One, all area underneath the graph has to be 1, and the mean is 2 pi squared plus 8. The really tricky part is the domain part. Right? So the rule of G should be okay to do. You just put it, substitute A and B in. But to apply the transformations to the domain of F is the tricky one. Easily and you can easily make mistake. So here's the solution again. Here's the solution. Question 5, which is the last one. There's a fire question here again. Okay. So we have f, which is e to the power of x plus e to the power of negative x. Then we have g, which is half times f, and then substitute 2 minus x. So we have a question that asks for the sequence of transformation to map f to g. Well, first thing you do, whenever the coefficient of x is not 1, you have to make it 1. So I take the negative out as a false negative 1 as a common factor. So it becomes negative bracket x minus 2, close bracket, close bracket. So now I can do it. Dilation of factor half, reflection in the y-axis, and translation of 2 units in the positive direction of x-axis. Okay. Two functions, g1, g2, same rule as g, but distinct domains, so different domains. g1 is strictly increasing, g2 is strictly decreasing. This is very problematic. It doesn't ask for the maximum domain, so I can give infinitely many domains. Well, I can choose from infinitely many answers. I have written the maximum domain here, so what I mean by that is this. Let's actually do it. So what have I got? Fx that I can define ex e negative x, and then g of x I can also define that's a half. That's gonna times f. And the question wants me to draw g. Let me get rid of the slider. Gone. Okay. And what else do I want? I want to get rid of that. Maybe get rid of that also. Why is this here? Here we go. So I need the part of the graph that is strictly increasing and strictly decreasing. Well, if you want the maximum domain for, let's say, strictly increasing, then it will be from 2 onwards, 2 to infinity, which is what I did write down. But 2 to infinity, I've written the maximum domain, but any infinite amount of choices can be made, right? So this part, right, from 3 to 5, let's say, if you pick any point here and any point here, that domain is also strictly increasing. And you can keep going, right? You can that's not what I want. Yeah, you can go further, right? You can pick any point here from 100 to 101. That is also strictly increasing. So the question says, give the domain for the inverse of G1, but it's really asking for the domain of G1 as a first step at least. So if we just want to find the domain of inverse of G1, which means we kind of have to find the domain of G1 to begin with, and it doesn't ask for the maximum domain and maximum range, we can give infinitely many correct answers. And you can pick anything bigger than 2, from 2.1 to 2.3 will be a correct answer also. And so that's very problematic. The writer should have written, give the maximum domain and maximum range for the inverse of G1. Same thing with decreasing. So it's not asking for G2, so it's fine. Let's leave it. But decreasing, same idea. You have the maximum domain when it's decreasing from negative infinity to 2, but then anything in the negative side can be also correct. Okay. But I have given the maximum domain of G1 and the maximum range of G1, which means the domain becomes range of the inverse, and the range becomes domain of the inverse. So you just switch domain and range, and you have the inverse domain and range. And then we have G, which is the thick solid curve. We have the inverse of G1 and the inverse of G2. G2 is written in drawn in the longer dotted line, and the G1 is in the thinner solid line, and you have a y equals to x as well. Pretty nice graph. And then the intersection point between y equals x, y equals to g, and the inverse of G1, G2 are labeled P and Q. Finding coordinates correct to 2 decimal places. So this is really just a calculator question. So you can, for P, just make gx equals to x. For Q, same thing. You make gx equals to x on your calculator, and you can find them. And find area of the region bounded by the graph of G, the inverse of G1 and the inverse of G2. G1, G2. So G is the thick one, G1 is the thin one, and G2 is the dotted line. So the area bounded by all three graphs is this shape here. Let me draw it. It is this shape here. Hopefully you can see my drawing. That shape there, or I can just circle it like this. Not circle, color it like this. So you may be tempted to treat this as two parts, so several parts really. And this is the annoying bit, right? So this part here really is made up of multiple functions, right? So you have three curves basically that define this shape. So that bit is the complicated bit. So you have to treat that. You have to sort of treat that separately to that, and then to that, and so on. Right. So a lot of work to do, but it's not, because if you realize it's there's a lot of inverses going on. So the area is symmetrical by the line y equals to x. So all you need to do is to find this area and times 2, and you should be okay because it's symmetrical. And this area is easy to find because it's defined by two nice graphs, y equals to x and gx. Just two functions define this area. So that's all we are doing. X minus gx, the two intersection points, times 2. Okay. And then we have a function we have function h, 1 over k times f, and then you sub k minus x into it, which I have written here. The turning point of h always lies on the graph of y equals to 2xn, where n is an integer. Find the value of n. So to find the turning point, we're just going to differentiate h using calculator and make it equal to 0. And it turns out x is k. Right, so turning points always happen when x equals to k. But then if you sub k back into the function, the y value is 2k to the power negative 1. Right? So turning points are always like this. K to 2k negative 1. That's the turning point coordinate. It's always going to be k when x equals to k. There's a turning point, and the y value is 2k to the power negative 1, always. Because that's what we get when we substitute k into h. Which means, well, the turning point has the format 2 times x to the power negative 1, right? If you, k is x. Here, y equals to 2x to the power n. There's no k. That's just because we're talking about a graph, and a graph of a function, so we need to change the variables to fit the axes, the x and y axes. So when you graph, you change the letters into x and y to fit the convention of the axes. But if you look at the coordinates, it's k and 2k to the power negative 1. Right? So and k is x. So really, it's because k is x, And then you just compare the power, -1 and n, so n is -1. Okay. And then we have h1. h1 is a function where the domain is restricted, right? If you look at h, the domain is r, all of real number. h1 is simply a domain restriction on h because the rule is the same. h1 is the same rule as h. And then you have the inverse of h1, which is a nasty thing, and it's given to you. And then it says, what is the smallest value of k such that h will intersect with the inverse of h1? Smallest value of k. And I think there's a restriction on k. Yeah, k. K has to be positive. K has to be positive. So you need to notice the previous question, before the previous question, just on top of it. K has a restriction, it's positive, and you need the smallest value of k. Okay, and you need h to intersect with h1. So let's do it. I have f already, so f is defined. Yeah, so now I just need to define h. Let me put k in. I might as well put k in here, so that I can take full control of my algebra in a moment. Okay, that's defined. Let's check. Yes, that looks good. So h has been defined. Yeah, okay. H has been defined. And the next step is to define what? Ooh. Something wrong with my keyboard. Huh. Oh, no. Oh yeah, it's all good now. Okay. H1, I define that, and that's going to be a natural log function. K over 2x. K over 2 times x. K over 2 times x plus 1 over 2 times square root. K squared times x squared. K squared times x squared minus 4 all plus k. All plus k. Okay, so I need h to intersect with h1. Let's do it. Yep, I need the slider. Here we go. Right, so here we can see the graph pretty easily. Let's get rid of that, we don't need that. Okay, let's start with 0. Nothing, right? It's undefined as expected because here the condition says k cannot be 0. That's expected. Now, 0.1 doesn't give us much. Yep, here we go. 0.5, they are here. And then if we keep increasing it, they get closer. Oh, sorry. 0.6, it gets closer. 0.7, even closer. So let's go to 1. They get closer still. 1.1, they get closer. Closer. Let's try 1.4. Oh, now they intersect. But I want to see the process of getting closer to each other. So 1.2, that's still not there. 1.25, now they're getting closer. 1.255, closer and closer still. 265. Yeah. So basically, I don't want this going on, right? They intersect when they intersect when k is 3, but that's not what I want. It says I need the smallest value of k, the smallest value of k. So k equals to 3 is not what I want. I want something, and 2 is not what I want either. This is not small enough because there is a smaller number. What did I did before? 1.5? No. What did I get before? 1.226 or something. Yeah. That's the smallest value. That's the smallest k value for which h intersects with h1. Oh, sorry, I shouldn't say h1. Inverse of h1. The rule for the inverse of h1. Yeah, that's a slight typo. I shouldn't have typed h1. h1 is not this function. This is the inverse of h1. Yeah, just keep that in mind. What I've typed h1, but the rule itself really is the inverse of h1. The inverse of h1. So and I need h to intersect with the inverse of h1. And the smallest k value that does that is this. So something like this, something like 1.26. Okay, this is a fire question. This is a fire question. I think I said that. Yes. Because I spent so much time on it and I tried so many different things. Again, I think I spent maybe more than 30 minutes on this. 30 minutes. And I tried so many different things before I got to the answer. And here is the answer. Here's the thinking behind it. When k is gradually increased from 0, and when h and the inverse of h1 first intersect, there's only one intersection, as shown by this graph. And I observe that this, because they're the inverse of each other, like this is the inverse of h, and this is h. The intersection between the inverse and the original most likely is on the line y equals to x, and I can check this. And of course it is. Y equals to x. So that's the observation I make. When they first intersect, when k is the smallest, and when h and inverse of h1 first intersect, there's only one intersection, and it's on the line y equals to x. This means, for the point, if I want to find this point, if I want to find this intersection point occurs when h is equal to x, because the intersection is between y equals to x, y equals to h, and y equals to inverse of h1. Okay, so I may as well just say the intersection is between h and x. So y and x is the line, and y equals to h, x is the curve. And also, y equals to x is the tangent to h at this intersection point. Look closely. Look closely. The intersection is between the blue curve and the black curve, the black line. So I can make h equal to x to find this point. But also, y equals to x is a tangent. Y equals to x is a tangent to the blue curve, because it intersects the blue. The black intersects the blue at one point only. It touches it. The black touches the blue at one point only, and it's a touching, not crossing. And it looks like a tangent. It looks like a tangent, and it touches once. It touches the black touches the blue once, which means if I differentiate h, if I differentiate h, the gradient of h at this intersection point should be 1, because the gradient of the blue curve at this point should be the gradient of the tangent. That's what gradient means. Derivative means the gradient of the tangent is the gradient of the curve. Let me rephrase. The gradient of the tangent line is the derivative of the curve. So the derivative of the blue curve at this point is the gradient of the straight line, which is the tangent, which is 1. The straight line is x, y equals to x. So the gradient of the tangent is 1, which means the derivative of the blue curve must also be 1 at this point. And that's what I solve. That's what I solve. Because, watch this. If I do if I simply do this, oh, sorry. I'm actually gonna, yeah, because this is the annoying thing about the CAS calculator. Because I've graphed it, I have graphed both function and I have a slider and I have set k to be 1.26. It now thinks k is exactly that, 1.26. So let me actually, I need to do this. So k is nothing now. So I did that because I remember when I define h, I'm defining h in terms of both k and x, and k is unknown. So in the input of h, k is there, and k is supposed to be an unknown. So I need to delete the variable k so that it's not 1.26 anymore. And you can go to the graph and you can see it's gone because k is gone. And I can then find k. Right? I need to make k the unknown so I can find k, not k isn't 1.26, which I previously set on the graph. So you can see this gives me nothing, right? So simply knowing the fact that the point occurs at the intersection between y equals to h and y equals to x doesn't give much. You need a additional criterion, which is the derivative of h at that intersection point is 1, because the tangent at that point is y equals to x, which has gradient 1. So let's try that. I'm now going to put that equal to x, and then I'm going to differentiate this. The derivative should be equal to 1. And let's find both x and k. And I have an answer. Right, so I make h equal to x, as well as make the derivative of h equal to 1, because that is the derivative at the point I'm looking for. So I do get some answer. But look at it. It's negative. I can ignore the x because I don't need it. I'm just looking for k. It's negative 1.2687. Negative 1.2687. So let's try that. Don't panic. Right? Well, you should panic slightly because k is supposed to be positive. That's what the question says. So the CAS calculator gives you a negative 1.2687. Okay, what do we do? Well, let's. It's the slider here. Can I bring that back? Yes, bring that back. Okay. Let's do it. If the CAS says k is negative 1.27, let's do it. Negative 1.27. Here it is. Yeah. One moment. Well, that's not what I meant to. Yeah, okay. If you're putting k equals to negative 1.27, you can see that it is that the two graphs are getting close, but they're not there. Well, at least they exist, so that's good. At least they exist. And then if you click the yellow one, it says many solutions may exist, and it says try specify appropriate lower and upper bound and or guess and so on and so forth. But I do not believe you can specify the domain when you are doing simultaneous equation. I think if you do one equation, you can specify the domain, but when you do simultaneous equation, I do not know of a easy way to specify domain for both x and k. If you do, please leave it in the comment. If you know of a way to specify domain in solving simultaneous equation, please comment below. But I don't know a way, so what I did next is I knew this was kind of the answer, right? So previously, when I simply played around with the slider, right, that was my first step. I just played around with the slider. This was basically the answer, but positive. So if I do that, here it is. Right, the slider does. If I how do I change the location of it? That will do. So if I put 1.27 in, I get a pretty nice result. Right? The result is true. They intersect only once, and that's the first time they intersect. So even though the calculator gives me negative 1.27, I'm pretty confident that it is now positive 1.27 will be another solution because it says more solutions may exist. Yeah. Let me try that. I don't think, okay, if I try this. Yeah, that's not gonna work. Yeah, so I'm not sure how to specify domain in hybrid function. Sorry, in simultaneous equation. But with that, I can conclude that k is 1.27. Okay, so even though the calculator gives you a negative answer, you can pretty quickly realize that if you change it to positive, you get your answer. Oh, 1.27. And it's a 1 mark question, so the answer should give you the 1 mark. Anime says it's possible for the graph of h and the inverse of h1 to intersect twice. Of course, we just saw that with the slider. Yeah. Oh no, I need more than that. All right, now here they intersect more than once, twice. For example, this occurs when k equals to 5. And find the area of the region bound by the graph when k is 5. So we could just come over here and make 5. And like this. And you can see the graph pretty easily. And it's just the red curve minus the blue curve. Yeah. So the inverse of h1 minus h. And you can find an intersection point, of course. Again, I would advise you not to do this. Not to do this. Because those numbers may or may not be correct. Right? The arithmetic that the calculator does in the graph page isn't really proper. You need to go to the calculator page to find coordinates and numbers. So you find intersection points, and the x values are the terminals of your integration, and then you do the inverse of h1 minus h, and you get the answer with the calculator. That is all. Thank you for watching.